Hello and Assalamualaikum. Today we are going to present about the solar water heating system.
The closed-loop active system is the one most commonly installed. These systems use flat-plate solar collectors, which have a plate of glass over a heat-absorbing sheet of copper plating, painted black. Underneath is a layer of insulation, and in between are rows of copper tubing that contain a non-toxic heat transfer liquid that gets hot when sunlight heats up the collectors. This heated liquid gets pumped through the copper tubing to a tubing coil called a heat exchanger in the solar water heater tank. There, it warms up the water surrounding the heat exchanger. When you use hot water in your home, it's drawn from your conventional water heater tank and is replenished by the stored hot water from the solar water heater tank. A mixing valve adds cold water if needed to ensure that the hot water is always delivered at a safe temperature. Cold water is pulled into the solar tank to replace the hot water sent to the conventional tank. Once cooled, the heat transfer liquid is pumped back to the flat plate collectors for reheating as the water heating cycle repeats itself. At night or on rainy days when the solar collectors absorb less heat, the conventional water heater will supply your home with hot water.
Integrated Collector Storage ICS system use hot water storage as part of the collector. As example, the surface of the storage tank is used also as an absorber. The main disadvantage of the ICS system is the high thermal losses from the storage tank to the surrounding, since most of the surface area of the storage tank cannot be thermally insulated as it is intentionally exposed for the absorption of solar radiation. Thermal losses are greatest at night and overcast days with low ambient temperature. Due to these losses, the water temperature drops substantially during the night, especially when the winter. In direct circulation system, a pump is used to circulate portable water from storage to the collectors when there are enough available solar energy to increase its temperature, and then return the heated water to the storage tank until it is needed. As a pump circulates the water, the collectors can be mounted either above or below the storage tank.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nushaira Fika binti Fadukaha, ID number TC17051. So today I'm going to explain about thermosiphon system, indirect water heating system and air system. Thermosiphon system passive. Thermosiphon system is heat potable water or heat transfer fluid and use natural convection to transport it from the collector to storage. The water in the collector expands, becoming less dense as the sun heats it and rises through the collector into the top of the storage tank. There it is replaced by the cooler water that has sunk to the bottom of the tank from which it flows down the collector. The circulation continues as long as there is sunshine. Since the driving force is only a small density difference larger than normal pipe size, must be used to minimize pipe friction. Connecting lines must be well insulated to prevent heat losses and stop to prevent formation of air pockets, which would stop circulation. This is the schematic diagram of a thermosiphon solar water heater. As the sun shines on the collector, the water inside the collector flow tubes is heated. As it heats, this water expands slightly and becomes lighter than the cold water in the solar storage tank mounted above the collector. Gravity then pulls heavier, cold water down from the tank and into the collector inlet. The cold water pushes the heated water through the collector outlet and into the top of the tank, thus heating the water in the tank. A thermosiphon system required neither pump nor controller. Cold water from the city waterline flows directly to the tank on the roof. Solar heated water flows from the rooftop tank to the auxiliary tank installed at ground level whenever water is used within the residence. This system features a thermally operated valve that protects the collector from freezing. It also includes isolation valve, which allow the solar system to be manually drained in case of freezing conditions or to be bypassed completely. Indirect water heating system active. Indirect water heating system circulate a heat transfer fluid through the closed collector loop to a heat exchanger, where its heat is transferred to the potable water. The most commonly used heat transfer fluids are water or ethylene glycol solutions, although other heat transfer fluids such as silicone oils and refrigerants can also be used. The heat exchanger can be located inside the storage tank, around the storage tank, or can be external. It should be noted that the collector loop is closed and therefore an expansion tank and a pressure relief valve are required. Not to be confused with a tankless coil water heater, though they are similar, an indirect heater uses a storage tank and the heat from boiler or furnace to provide home with all the hot water needs. In an indirect system, water is heated up by main boiler or furnace through a heat exchanger attached to the space heating unit. That water is then moved by the water heater into a storage tank, much like a traditional water heater, where the hot water is kept until it's needed. This is the drain-back system. Drain-back system are closed-loop indirect active system. A heat transfer fluid, HTF, usually water, contained in an unpressurized closed loop is pumped through the collectors and is separate from the end-use water being heated through a heat exchanger. When the pump is off, the heat transfer fluid drains out of the properly sloped collectors and pipe, leaving them empty and protected from freezing. Air system. Air system are indirect water heating systems that circulate air via ductwork through the collectors to an air-to-liquid heat exchanger. In the heat exchanger, heat is transferred to the potable water, which is also circulated through the heat exchanger and returned to the storage tank. The main advantage of the system is that air does not need to be protected from freezing or boiling, is non-corrosive and is free. The disadvantage are that air handling equipment, ducts and fans need more space than piping and pumps. Air leaks are difficult to detect and parasitic power consumption is generally higher than that of liquid system.